So welcome to another edition of Pulp Nonfiction. Today I have with me Cliff Ruddle, a gentleman who does a little bit of endo from time to time. But more importantly, you've been married 52 years and is still alive. And you have two, obviously you're a man who listens. And you have 2 children and more importantly, 5 grandchildren. Well, congratulations.
Thanks, Joel. I just want to say how happy and delighted I am to be with you today. And although I've known you by reputation, the rest of the audience should know that we've actually never shared a dinner together. We've never really had exchanges except we know each other from a distance. So I'm just happy to be with you. And I like what you're doing in Canada. And I really hope that your work can go forward to take endodontics to a new future, a better future.
Well, thank you. Yeah, we're and the future is going to be interesting and a lot more different than we thought it was going to be about 4 months ago, I imagine.
It's really changed fast, hasn't it?
The good old days, like in February.
Yeah, it all changed overnight, almost overnight.
Yeah. And hopefully, we're coming through. We're going to have a new era. We'll be able to work again soon. But in specifically in regards to you, I noticed 13 inventions. Is that right?
I don't know. I've done quite a few inventions over the decades. It didn't happen in any one year or 2 or 3, but over time, yes, I've invented a few things. I'm proud of it.
Yeah, and I the Pro Taper file is the that's my youngest son there, Jack, just sneaking in. He's actually a Texan. When I had him when we were down in the endo program down in Texas. So it's kind of funny whenever we travel, we cross the border and they're like, 4 Canadians and American. Oh, he's Texan, like real American.
Yeah, that's a big American.
Yeah. Not from one of those wimpy states, Texan. Anyway, I digress. The Pro Taper file. Now that it's with the new metal, has the SX file changed over time? Because I remember back in the day, the SX file, people either loved it or hated it. And now with the new metals and all that, I'm not hearing people love or hating the SX file nearly as much. But I think it changed, didn't it, with the new metal?
Well, so you'll know, Pro Taper, we started working, I'm telling you a little more than you asked. We started working on Pro Taper in 1995, and it didn't launch till 2001. And from 2001 to the current day, it has exactly the same geometries: rake angle, helical angle, cutting angle, taper pitch, all that's exactly the same. The only thing they did is after the file is physically machined, they put thousands of them in cassettes. They go into an oven, they go up to a proprietary temperature, then they take them out of the oven and they cool down to room temperature and they get that oxide of gold. If you cut through it, you'll see it's silver inside, but that's called gold treatment. So some heat treatments are pre-machining and some are post-machining. So Pro Taper Gold is post-machining. So Pro Taper Gold, the only difference between that and its previous iteration is heat treatment.
Okay.
So back to SX. You either loved it or hated it. I thought that was a perfect description. Doesn't hurt my feelings. That's a very honest and accurate thing. It has now turned out over the years to be the #1, I don't like the word orifice opener, but people call it an orifice because to me it does body work. It's more than just the orifice, but it's the #1 sole file in the world to open up the body of a canal, remove interferences, triangles of dent and stuff like that. So it's just heat treated now. You're right, gold made it softer, more flexible. So some of my endodontist friends would call up and say, I moved over to gold, but I still use the SX initial instrument because it was stiffer, and I like to get the tip of it into like an MB2, me and you know this, but really light, because I don't teach putting mechanical instruments below the orifice unless there's a glide path. So we're talking initial endodontists, they're light touch, soft touch, and they could just kind of peck a little bit at that orifice and start to get the instrument in there, and it was stiff. Gold wouldn't do that. So I got complaints from the gold guys, it's too soft. The other guys said the other ones were too soft, they prefer the stiffer. But right now, I think it's been some years, and pretty much everybody that was on Universal went over to gold because there was tremendous efficiency. We actually got a more conservative shape. You might not think of this, but when an instrument's going around a curve, and let's just say they're exactly the same taper at every cross-sectional diameter of comparison, it's exactly the same, a non-heat treated instrument will make a bigger hole because it's going to ride on the outer wall. And even if it can flex and eventually fall the pathway, your hole's going to be a little bit bigger. So when people went to gold, I heard three things. It's not doing very much. I can't hear it doing very much. I look in my mouth mirror. I can't see that it's doing very much because it didn't have to work as hard. It was following the canal more. So we noticed that if you look at post-op films, yours, because you could compare perfectly like 5 years of that and 5 years after gold, your bodies are going to look just a little smaller.
Mm-hmm. Yeah, yeah. Transportation's noisy.
I guess we should tell the audience your father was an engineer.
Yes.
And you have a son that's going to be an engineer.
Yes.
And I just didn't want the audience to think that it skipped a generation. Joel's an engineer. Anybody that does dentistry to some extent engineers bridges and splints and implant loads, and we have to think about all that. But Joel would be able to use those abilities now moving on to endodontics, because engineering, you get electrical engineer, chemical engineering, you could okay.
Oh, no, absolutely. Yeah, no, it's, I mean, the big thing about endo is you're working where you can't see it. And so you're relying on instruments and you're relying on elegant engineering to get things done, because any Tom, Dick, or Harry can hog a tooth out, but can we get, cleaning done efficiently and elegantly and effectively, right? And that's where the beauty of the engineering comes in.
So I'll throw a curveball at you.
Yes.
Joel and I didn't rehearse this, everybody. But I guess, can you see this, Joel? If I keep talking, do I get the screen?
Yes, yeah, you got the screen, so I'll stop talking.
Screen, you can see it?
Yeah.
Well, this is the little green Bible. There's two of them in North America. One's in the Library of Congress, and Ruddle's got the other one. But this is Walter Hess's book.
Oh, right.
And it has all these plates,
yeah.
Every tooth in the mouth. So when we talk about engineering, everybody, it's engineering for the anatomy that we deal with. And so I really loved the anatomy as a resident back in the 70s, the mid 70s. And so my mentor, when I was done, he had this book and he said, I want you to have it because out of all my students here, you seem to be the most enamored and passionate about root canal systems. So I trained at UOP, University of Pacific in San Francisco, and everything was a canal.
Yeah.
And then I went back to Boston. They said that you can't say canal. There are no such things as canals. We treat systems in Boston. So anyway, it was just a language thing. But you and I know as the years tick by, how we communicate is how it is. And
yes.
If we think we're treating canals, we're probably going out in the marketplace and getting stuff to treat a overly simplistic canal. If we say systems, it begins to inspire like, oh, the instrumentable portions, the non-instrumentable portions, how do we get reagents in there? Why do we shape canals? And all of a sudden we start to, our engineering now can be applied to root canal system anatomy. So I wanted to tie our anatomy back to your engineering background.
Yes, no, absolutely, yeah. Our instruments are round, but the canals are rarely round. And if we end up with a canal that's completely round, perhaps we've overshaped it. But yeah, no, I remember those Schilder dye shots. Those things are famous, and it just, when you see those, you keep thinking, because we're always used to seeing the X-rays, the white stripes, and then there's so much more about the white stripes. It's a system.
Yeah.
Yeah, and then that's a remarkable thing. I mean, I'm sure you've come across it when you have, those root canals done many, many years ago, and they're short and they're thin and wispy, and they're successful, and beside it you have a beautiful looking endo done a few years ago and it's infected, and you're like, that's the beauty of endo. It's not all about radiographic aesthetics.
Yeah.
You know, and
Yeah, my mentor used to say to me, Cliff, are you treating the film or are you treating the patient?
Yes. Yeah. No, I'm absolutely. Yeah. No, it's there's so much there. And speaking of which, a couple of interesting developments. The endo micro brush. I was quite intrigued by that when I saw that. You have the ultrasonic and the rotary, and you're looking at those. And because I love the endo activator. I'm a big endo activator fan. You know, active irrigation. And I remember someone was talking to me, and it was a good analogy. You know, you get your car washed, you just don't have the garden hose on the car. You got to give it a little bit of scrub, which is like the endo activator. And then the micro brushes, how are those coming along? Because that's new and it hasn't been released yet. You're working on that, is that right?
I'm smiling because sometimes, Joel, things in life don't go exactly as planned. So one of the things that makes you successful is we have to be able to adapt.
Yes.
So I'll tell you this briefly, but many years ago, more than 20 years ago, I thought, well, we brush our teeth, and we have they're on in brush technology they call them arms, but we in Bristol's we say bristles. But if you're making that for an endo, you'd say arms. So anyway, we brushed our teeth with bristles. The bristles could collapse around an irregular morphological shape, and we could make more bristle tooth contact, and we could clean pretty well. So I thought, well, these shapes are totally, the cross sections are totally irregular. There can be rounder ones, but there's certainly ovoid ones, figure eight ones, thin isthmuses, shoulder collos, like flags flying in the breeze. So I thought the brush isn't going to get into the deep lateral anatomy, but what if I had the bristles hit the shaped part of the canal? That could help get the smear layer off, open up the secondary anatomy, and then another technology could begin to agitate a solution. When we agitate a solution really almost violently, we fracture it. And if you fracture a liquid, at the liquid fracture interface, there's bubbles, and they begin to expand because they're unstable because of heat and pressure. When one single bubble implodes, it sends out 40,000 shock waves. So how the endo activator works is it works by bombardment. It's not your ultrasonics with eddies, and it doesn't, you know, they talk about acoustic streaming. Those are terms that tied to ultrasonic technology, but that's not the endo activator. So anyway, I wanted to make a brush. So we tried 7 different countries, probably 15 or 20 different shops. I mean, really sophisticated shops. I went to Plastic Valley. Plastic Valley is like Silicon Valley, except it's over in France. It's on the eastern part of France. And in this little valley, they can make things all the way with injection molding, the size of a half a car. So we saw them in one, sound like an endo world event, huge noise, and boom, they break it out of the mold, and there's half of your car. And then the other half's over here. Then they had to, boom, put them together, and they had a big laser, and then lasered them together, and you had a car. Okay, so they could do gross macule things, but they could also do nano things. So I went there because I thought for sure we're going to be able to make a brush. The problem is it was, first I was doing braided wires.
Yeah.
And you lay the 2 wires like this, the stock goes between, then you have servo motors, and they use torque, and they wind them up and capture your arms, and you have a tapered brush. The problem was in the early days, each wire was 0.2 of a millimeter parallel, so that's what they could do in industry, 0.2. Well, your brush is already 0.4 and it's nude apically. Yeah. So 5 years later, after I spent a lot of money, we were able to make a tapered wire. Okay, so now we had a bigger cross section up in the body, so we could really brush, and it wouldn't just be too wimpy. And then down deep, we could get smaller than 0.2, so we could get to 1/1500ths. And so now we were 0.3 bald, but we could put arms on it. But anyway, we did a lot of brush work, but the common problem was I wanted to get a brush down to about 210s to 2500s.
Mm-hmm.
And I could never do that with braided wire. The last company I worked with was the biggest brush company in North America. It was called Gordon Brush, and they're in LA. And they said that they would have to make new servo motors because with something that small, you can't just start running a torque to capture the arms or you'll break the end of the wire. So you have to have a smaller, lighter torque, as you would think, towards the distal end, and then you need a bigger torque in the middle, and then in the coronal third of the brush, you can even have a bigger torque. Well, those motors cost $750,000 to build. And so I was telling Phyllis, we just have to somehow do this. But that journey took me to injection molding.
Mm-hmm.
And I was fishing with some guys in Alaska, and I'm not a fisherman, but I'm in a big group practice, about 25 docks. Every year they go to Alaska, once a year, about 15 of them. So
Mm-hmm.
in 1 year, I just said, yeah, I'll go. And I wasn't going to fish. I wanted to see Alaska. And I thought being out on a little boat and trolling along to get salmon, cohos were running. So I thought this would be really great. So I watched these guys throw their lines out. I didn't do so well with my fishing, but they did. And I noticed when I went home, they had more fish than me, but I had an idea. And my idea was I saw them throw this line out. It was flexible. It never broke. They slowly would let the salmon play, but bring them in, let them play, run, bring them in. Finally, I went home and I thought, if I can use a polymer, it's flexible, it's non-cutting. If I could get that activated below the orifice, I can do that right now. So sometimes in life, we have to remember the old expression, don't let what you can't do interfere with what you can do.
Mm-hmm.
So what I could do is I could make an endoactivator tip.
Yeah.
And so we did that. The brush thing lays over here in my mind permanently. I still think it has application. It would be very affordable, probably $3 to $5 a brush. And all of a sudden, when we think of some of these expensive, you might get into it later, but 70,000 propositions to clean a root canal system, it brings it back to, I don't want to be a teacher of the elite. I want to be a teacher for the masses, and I want to help be like a rising tide that raises all ships. And so when I teach around the world, I go to Southeast Asia and they get $50 for a molar. Yeah. And they can hardly even afford the motor itself, much less, throwaway items. So I know that a lot of this, like an ultrasonic piezoelectric thing, they're just not going to buy it. If you're a specialist, you will to knock a post out or a broken instrument. So anyway, the brush was a failure. It led to the endoactivator tip.
Oh,
and
okay.
Currently right now, as we speak, nope, I don't have anything to show you, but it's at the office. We're working on new designs, because if you and I were to go off your beautiful shores of Vancouver, mm-hmm. and you said, Cliff, we're going to be in what do you call them, a skull or something, and or you might give Cliff the round tapered oars, and you would take a paddle. And when you went like this, you're displacing a lot of water and you're getting forward thrust. Yeah. When I'm doing this, I'm sitting there watching you disappear. Yeah. So my tips right now are tapered and, as you know, round. And so we're working on different offsets. In other words, you can have a tip come out of a handpiece centered. Yeah. You can have it come off axis so you get a bigger whip. So we're playing with S-curves, cup shapes, not this, paddle shape, not round. So we're doing a lot of that. When I do about 6 more weeks of work, then what we do is we'll give them to a university. They'll run some control groups. I'll call this quick and dirty. And we will evaluate very quickly, like on 10 canals, which of the 6 design features seem most promising. There'll probably be 2, and then we'll take these 2 and exploit their designs further, and that'll take us closer, and then we'll get them off to the university and let science tell us how we're doing.
That's fascinating. Okay, yeah, it's marrying the 2 there.
Mm-hmm. Back to the brush, I don't know if I can do it. We went from braided wires, and then we started doing injection molded brushes. Mm-hmm. But when you open a mold has 2 halves, and the cross section is going to be round, so you pull a lot of arms off.
Yes. And
the audience can understand that, right, Joel? Or you can explain it to them more. But if you have 2 round pieces and you pull them apart, mm-hmm. some of these radial arms are going to get pulled out inside the mold. And then you have a brush that has a denuded area of arms. So I really, I love the idea still. I haven't been able to pull it off.
Yeah. Well, and sometimes the elegance of a single, you know, activating tip, because if you have all the brushes, you have all those little micro things that could break off. And the nice thing about the plastic of the endo activator tip, I mean, I remember you presenting about it. I mean, this thing is, you know, that plastic is indestructible.
You know, it's really neat when you look at polymer chemistry.
Yeah.
There's over 1,000 polymers, and so in combinations you can make infinite molecules. So it turned out that in the world below the orifice in medicine, they use Delrin, and that's the most pure grade of polymer chemistry you can implant it, and orthopedic people use it. So that's why we chose Delrin over nylon or any of a number of ones we could have. And then of course, different plastic have different elasticities, and you'll get different, you know, motions when you begin to agitate it and drive it with a motor or something. So it's all interesting to see how all that works.
No, absolutely. So the Ruddle solution, is that something that's okay?
No, I'm not doing it.
Yeah.
What I did do though many years ago, and everybody on this webinar can do it, I learned this from Professor Mosh too, who's my dearest friend in endo. I've known him since I first gave my lecture in Paris at the Société Odontologique de Paris. So they had a big congress there, and he was running it, and he'd invited me. I never met him. It's kind of like me and you. He was a delightful man. He was fabulous. He was a big thinker. He was really brilliant endodontically. So we became fast friends. And then he started sharing, I was sharing, we were both sharing. It was funny from distance. He was doing things I'd never heard of, and I was doing a few things he said he was learning. But one of the things he did is he used Hypake, Hypaque. It was used in medicine for many years, and they would inject it into a vessel. It would perfuse through the systemic circulation. It was a radiopaque contrast dye, and it was used in cardiology to look for occlusions, narrowing of the arteries, you know, blockage, like I said, occlusion. So cardiologists use it as a diagnostic contrast medium. Well, Pierre began to use it in the teeth. The only reason not to use it in the teeth is that if you have a patient who has an allergy to iodine. So if there's no iodine sensitivity, if you can put it through the systemic circulation, you can put it in the tooth. And the tooth, it's about as white as radiopaque calcium hydroxide. So we were using it to map resorptive areas. We were mapping curvatures. We watched our shape get bigger and bigger, but Joel, this is what was most fun. We saw it working laterally off the body of the canal, working out into a not seen lateral canal, but, you know, radiographically we saw the lesion, but radiographs just show us a resolution about 50 microns. So we never saw the actual lateral canal. We just saw the evidence of it, the lesion. So we could see over the protocol time, which was 1.5 minutes, we could see that Hypake move ever closer out here to the lateral caval surface, and then we would see it puddle. And that doesn't show, the histologist on the phone will say, Ruddle, that's ridiculous. It showed that it went there, but you didn't show us it was histologically clean. That's another study, and that was done. So anyway, long story short, we were watching Hypake to show more how the hydrodynamics of the Hypake worked during clinical activity. We could look at reversed apical architectures. We saw some fractures. We could see it go into like a trifidity at the end of a shaped canal. So it was really fun. I have about 100 of those histosections on patients of record showing Hypake moving out. And then we have 19 peer-reviewed papers with the endo activator. I'm very proud of that. 19, and there's not one of them from the same university. They're 19 separate universities. Pierre was at Paris 7 as Professor Marchetou at that time. So his students, slaves, they developed a protocol, and then we gave that protocol to the other universities. And it turns out that any university in the world, if they follow the protocol, they can get the same results. So we have 19 peer-reviewed papers. We have about 90,000 international users. And I think it's not a laser, it's not gentle wave, it's not probably some of those more lofty ideas, but it's less than $2 in the US per patient.
Yeah, that's absolutely fantastic. And the HiPake also, when you talked about the air bubble and the airlock, Herb Schilder used it back in the day as well, and it, because it's not so much a controversy now, but back a couple years ago, everyone was saying, "Oh, you got that air bubble at the end, and you can't penetrate it, and all that." And the
Joel, did you believe that?
Well, no, because of HiPake, right? I mean, you would see all those Herb Schilder ones, and it'd be like, if you were actually working in a canal, it gets to the end. But
let's talk. Can we talk about that a second? Because you and I are talking about something that for us, it's old, we understand it, but our audience, I don't know who our audience is, and I'm not asking, but we have, I assume on this call, you have, there's that old expression in life, who you are is where you were when. So we have it depends on where you went to school, who's your mentor, what you packed in your bags, what you jettisoned, what you hung on to and left. Then you watched Joel give a lecture. Then you went to your meeting up there, PAC, Pacific, what is it? The Pacific Dental Conference. PDC. And anyway, you get a tape, you go to a lecture, you stir it in a soup, and that becomes who people are. Yes. So what Joel's talking about is never was this controversial. To me, it was a sales gimmick, but it was a whole histological story was made up about our irrigants never got to the last 1 or 2 millimeters because there were, as Joel said, a vapor lock. If you believe that there was a vapor lock, then I'll tell you you'll believe anything we tell you today. Now, but I will say this: if a colleague is working short and the end of the root is blocked, yes, you can have some vapor locks. But see, Schilder always taught us what? Patency. So we always cleared the mud, moved it into solution, and re-irrigated to liberate that debris. Our HiPake studies that Joel just talked about, we showed HiPake right to the radiographic terminus, which is a point minutely beyond the foramen. Yeah. Okay. In other words, we could prove it's not an airlock.
Yes.
It was to sell Endovac.
Yes. Yeah. No,
Endovac preached the vapor lock so they could move units.
But yeah, and so when we're on a really interesting thing there with the air bubble and all that, and I also. Another thing was getting the needle tip to with 1 to 2 millimeters and the side vented. And, I fell into that trap too. You read 3 or 4 articles about it and all of a sudden it's gospel. And then you're thinking, I'm not really comfortable getting it that close to the end. And is side vented really going to save me? If your needle's locked and you create pressure, does the pressure say, well, it came out the side, so we're not going to go we're not going to go by the path of least resistance. Like, isn't it just going to go where it's going to go?
Joel, we'll have to do another one of these sometime. Maybe look a little bit at some data and stuff. But I've really never been a proponent of, I'll just tell you what I see. I've been doing this for this is my 49th year in endo. And I've been teaching for about 45 of those years. So 45 years, here's what I see. As we show more and more anatomy, everybody knows that there's more. They know there's a little more. So what they do is they want to irrigate a little better. So industry goes, well, how can I help these guys and gals irrigate a little better? Oh, we'll make smaller cannula. So the gauges have gotten smaller. When we got down to about the limit of stainless steel, they went NiTi, because they could get us deeper. Now you can go around the curve. And I mean, I never have taught this. Why? Because I have SEM from a kid from the mid-70s showing shaped molars, MBs and MLs of lower molars. I never put my needle any more than about, let's just say the coronal 1/3 for fun. Coronal, middle, apical. Each third is about 3-4-5, 3-4-5, 3-4-5. Roots are about, if you look at all the teeth on the planet and did a bell curve, teeth are about 19 to 25 millimeters in their overall length. So 10's clinical crown. So 10 from 19 is 9, 10 from 25 is 15. Roots are 9 to 15. That's for the audience. That's where I got the 3, 4, or 5. So my cannula is never going more than about 2, 3, 4 millimeters into the top of the canal. I always keep my hand moving, but we drag our irrigants down the canal as we clear debris out and actually have a lumen and not an obstruction. As we improve our shape, if we look at hydrodynamics, we can see surface tensions reduced and irrigants move deeper. And then a little trick, I don't have a syringe here, but most people hold a syringe like they give an injection. So there's a plunger and their thumb's on the plunger and they push on the plunger and slowly dribble out anesthetic in front of the needle. Well, what I do is I put the plunger against the palm of my hand. There's 2 wings, and I take my thumb and I pull, push. Try to do this better. Pull, push, pull, push, pull, push, pull, push. I use a 19 gauge needle. It's open-ended. I do not want side delivery. Side delivery was to reduce sodium hypochlorite accidents because they were getting us so close to length. So I'm only in the coronal 1/3. I'm doing my first irrigation positive because that kicks out gross debris. You'll block the lumen of a 29 gauge needle immediately if you start vacuuming right away. But once you irrigate and the assistant's in there with the suction and you see your pulp chamber in your mouth mirror, it's clearing, well, then I'll start bumping my solutions. So anyway, I have high-pake studies on patients of record that I can bump irrigant 6 to 8 millimeters apical to the cannula. Now, you know, and I know, and all the endodontists on this webinar know, the literature is replete with many, many articles that say you can only irrigate 1 or 2 millimeters apical to the cannula. Therefore, we must get the cannula deeper and deeper and deeper because that's where the ball game is. That's where most of our anatomy is. So I just, I don't want to make anybody wrong. I'm wrong as much as anybody else, but I think it's how we look at it. So if you look at it that way and the way they do it, you can say that's accurate. But if you said, what if there was another way to irrigate with a 25-cent handheld syringe, and we don't have to go around curvature and get close to length, and we can still irrigate in a open lumen, even if it's tapering, we can bump solutions and we can prove it histologically. We can open roots up and clean it. So I'm not a big proponent of getting real close to the length.
Yeah. No, absolutely. And that's something I'm playing with a little bit. And I fell into that trap a little. I'm not that comfortable going down. And, you know, and then you see those high peak studies and wait a minute, they got it down there before. And yeah, it's always good to stand back sometimes and question what we assume is the way.
So Joel just told you one of the most important part of this webinar, and I learned this from my mentor. I loved him. He was, his name is Alvin Arlen Krakow. He passed away last year, and he was my second father. He was Herb Schilder's second student. So Cyril Gom and Al Krakow were in the first class in 1960 in Boston, at Boston University. So I got into Herb's program, but I also got into Al Krakow's program, and I went to Al's program because he was a guy that I thought I could maybe flourish at that age where I was insecure. I didn't know what I didn't know. I was 3,000 miles from home. I'd never been on the East Coast. So Al Krakow and all the faculty, it looked like a place where Ruddle might be able to thrive. So anyway, what he said is, always ask yourself, he said, even when I'm speaking, when I'm the lecturer, ask yourself quietly, don't say it out loud. Is it true?
Yes.
Is it true? Always question, is it true? Because we do things over and over because Harry said to do it. My mentor said he did it. 2 articles said they did it. Okay, it's true.
Yeah, must be.
Must be true.
Must be true. Yeah, and that, I think that dovetails perfectly into minimally invasive endodontics. The controversy in that, and I'll tell you a little funny story leading up into it. So I worked with an assistant and she worked with an endodontist back in Ontario, and then she moved out to BC, and she's like, well, I like working with endodontists, so I'm going to work with an endodontist out in BC. And so she worked with me. And the endodontist that she worked with in Ontario was a big, minimally invasive fellow. You know, the little ninja preps and the whole bit. And it was interesting to hear her perspective on it, because you know, he was pulling his hair out on cases. You know, whereas
I bet he was.
Yeah. Whereas I tend to go on the approach, I want it as small as I practically can, but not to such an extent that it's driving me crazy. And, you know, from her perspective, it was like they had a hard time taking working length films because we couldn't get all the gutta-percas in. And his cases took longer and all these obstacles, but he was so minimally. And I was like, well, from what she said and from her perspective, it seemed like he overcorrected for it. And when it was funny, when she was working with me, I was doing this upper second molar and I had a crown on it, and I was accessing through it, and then poof, the crown came off pretty quick. So I had a tiny little hole. And anyway, I did the root canal, and then I re-cemented it. And I was so tempted then to post that as my access. But I didn't. I was honest. Beat that.
Great.
You know? Yeah. But yeah, that's quite the trend. And it's, you know, one of the interesting things, and I didn't realize it up until recently in some discussions, is some of the endodontists or people reporting it are saying, you know, it's okay to leave some material in the canals because you could still get full healing, and you're preserving tooth structure up front. Like, you're moving away from the cleaning aspect of it, and you're like, oh my goodness, that seems to be the wrong way to go. Anyway, speak to that. What are your thoughts?
Yeah, I'm getting in trouble here, Joel. I have a lot racing through my mind. I've written about 8 or 9 articles on minimally invasive starting about 5 years ago.
Yeah.
So I'm going to be a little bit cocky. I don't mean to be, but it could come across that way if you don't know me, but I try to be humble. But in 1995, I said earlier on this webinar that we started our work on ProTaper.
Mm-hmm.
John West, his idea was to change the taper on a single file. Okay, nobody had ever done that. Buchanan always likes to say, yeah, I have different tapers, 4, 6, 8, and 10, but they're fixed tapered on every file. So he says he has variable taper. That to me isn't variable taper. We have variable taper, various changing tapers on a single active portion. Now, we realized in 1995, and we were still pretty young back then, we realized the shapes could be a little more conservative because there's this thing called external root anatomy that you and I always have to think about. And so for an example, everybody on this webinar knows that the lower molar mesial root, if you do a cross section right off the floor, it's going to have probably a concavity. And sometimes based on your CBCT or multiple horizontally angulated films, you can begin to see those 2 lines open up and close down. The more you can open up those little lines that represent the edges of the outside of the root, the deeper your invagination. So you know this, endodontists know this, but for the general dentist, external anatomy, really, sometimes when we're through shaping, we're pretty close to the cavo surface. 2, we might be so close that we've predisposed to a longitudinal fracture.
Yeah.
3, we could actually overtly strip perf. So we realized it would be important to reduce the tapers on the back end of the finishing files. So that was 1995. We didn't even know the words minimally invasive endodontics. We just knew tooth preservation wasn't a bad idea. And if you stand in the shoes of the restorative dentist, obviously we're a team and we need to get everything cleaned out like the extraction. And then they need to have enough tooth structure that they can do their magic mechanically and with adhesion dentistry to do the rest of it, the Farrell effect. I want to say the audience, Farrell, say it 3 times, the Farrell. You got to have it. Circumferential 2 to 3 millimeter collar of dentin. We don't just rely strictly on bonding. Bonding breaks down over time. Things move at different coefficients of efficient of expansion, contraction. So materials are moving at different rates and things open up. So we need the Farrell. So anyway, we had a pretty good idea back then. As an example, our F2, that's our finisher 2. It's a 25 at the tip. It has 8% in the front end only. But if you ran that 8% out over 16 millimeters of blades, you would be at 1.52. So for the audience, you would be bigger than a Gates Glidden number 6.
Yeah.
So how do you still get 8% and leave it more conservative? You do John West's thing where you have regressive tapers. So the 8% becomes then at D4 becomes 7.5, 7, 6.5, 6. The back end, you might have 5% taper. So what I want to tell the audience is at the last cutting flute, we're about 1 millimeter, not 1.52.
Yeah.
So if you build your file and it's designed right, that was IP, then you can have in the ProTaper system, you can have conservative bodies and still have full shape for irrigation and filling root canal systems.
Mm-hmm.
So minimally invasive endodontics has been, we did that. The instruments came to market in 2001. So it took us 6 years of R&D and field testing and histology and all that. We launched 2001. We had minimally invasive. Actually, let's give Steve Buchanan. He had the first minimally invasive instrument. His instruments had taper, but when the taper hit 1 millimeter in cross section, it became a shaft. So there was no more cutting flutes. So everything had an MFD, maximum flute diameter, 1 millimeter. Yeah. So different people at different times have had different ideas. The new people, I'm skipping now from that era, the mid-90s up to now. This thing about 5 years ago is so commercially driven. That's my opinion. It's to sell stuff. Because Schilder never gave a number, did he? He never said all foramens are 30. He never said they were 40s. He never said they were 20s. He said as small as practical. He said it's a continuous tapering preparation. He modified that over the years to say, at least in the apical 1/3. That's our capture zone. That's what holds our reagent inside the canal, the taper. That's what holds our gutta percha when it's thermal softened, keeps it confined inside the intaglio of the root. So people that aren't instrumenting much, their apical thirds are more parallel, and they're wondering why they're having more accidents. Yes. So I won't name it now unless you bring it up later, but there's a group of people using highly expensive technology, and they're reporting a lot of bleeding, they're reporting a lot of post-operative pain, and that's because they're doing minimally instrumentation. Joel, I'll come back to you. I'm doing too much talking, but you did talk perfectly about traditional access, ninja access, and we should add one more just for completeness, orifice-directed access.
Yes.
Well, all the studies in the last 2 years have shown these things are fraught with problems. We have more mechanical problems, more blocks, more ledges, more missed canals. We can't see fractures running down the axial walls of our access cavity. We're leaving crap up in the roof, so now they're building brand new for sale stuff that can clean up into the cornices and the horns, stuff they didn't get out. So every step is harder, and you know from teaching, I know from teaching, the beauty for a dentist, you get the wow when you just help them open it up a little bit and they can look down there and go, I can do it.
Mm-hmm. Mm-hmm.
If you can see it, you can do it.
Yes. Yes. No, absolutely. And
so I think the pendulum swung too far.
Yeah.
I think it was too big in the 50s, 60s, 70s, and 80s. And so always in life, the pendulum's always going too far one way, back the other way. The middle's going to be appropriate, root appropriate shapes.
Yes, absolutely. And traditional accesses, the big old accesses, reduce tooth stiffness by 5%, but an MOD prep reduces it by 60%, yet we're beating each other up over endo accesses, and yet you're still doing your MOD preps without, you know, I mean, yes, I know there's a little more less invasive MOD preps now than there was, but it's like, well, hang on a minute.
But
you got an MOD amalgam or composite in a tooth. Is your prep really going to bring much to the table?
Audience, it's critical, is you told the audience, if you look at the literature now, let's look at the scientific literature, you just said it. Mm-hmm. The biggest prognosticator for a longitudinal fracture is a previous MO, DO, or MOD.
Mm-hmm. Yes. Yeah.
Not so much you or me.
Yeah. Yeah. Yeah, we happen to be doing a lot of endos in teeth that have MODs, and they're cracking. And it's like, it's the endo. Okay. Yeah. The solution is to do more endo on virgin teeth. We'll look better.
On virgin teeth.
Yeah. Restoration free. But yeah, speaking of which, Yes, the how is the experience down in the U.S. with that system, the wave in your
Gentle
part of the
wave?
world? Yes.
Okay, well, I just did, with this lockdown, in
Yeah.
fact, not that you asked, but just for fun for our listeners, the last time I lectured
Yeah.
in front of an audience was at the Pacific Dental Conference. And I didn't realize when I flew out of there, I had a lecture at Kansas City. Stuart Walling's on this. He's the only guy I know for sure, but he'll tell you 2 weeks later, I was supposed to be at the George Hare Study Club in Toronto, canceled. I got something this morning from the World Organization, International Federation of Endodontic Associates, canceled. Just an online meeting. So I've been doing 2 or 3 webinars every week since pretty much about 2 weeks after PDC.
Yeah.
So because I'm coming to your question, because I'm doing more webinars, this group wanted me to give a webinar to endodontists only.
Yeah.
And I, just like you, I said, I don't need to see the questions, but they should have said they're all gentle wave users. So if you want, I'll give you my quick perspective, and I want to start off with being really fair, and I'll say the best that there exists with that technology.
Yeah.
First of all, I know quite a bit about it. I went down several years ago and spent one day at Son Endo. One day, I was with engineers. I was with the owner, well, not the owner, but the head guy, CEO, Bjorn Bergheim. I was with, I saw clinicals. I saw everything. That doesn't make me an expert. It just means I opened my eye. I now have talked to many, many people since then. There's now about 750 users in the North America market. I probably talk to 150 of them regularly. I get emails that are this thick, and I had to keep all these emails to document what I'm going to tell you because I'd probably get sued, okay? I know the field's different than it used to be. So I'll start off by saying it's very interesting technology, and it cleans root canal systems. So everybody, did you hear me say it cleans root canal systems really, really well?
Yeah.
That's about all the good things I have to say because it costs a lot of money.
Yeah.
Now, maybe an endodontist can go buy one, but they're $70,000. The handpiece is disposable and it's thrown away between every single patient. Based on volume, the handpiece could cost you $75 to $100. So the first comment is it's pretty expensive technology. And if you're going to get the technology, the question begs, are you going to be able to treat root canal systems? That's why you would get this technology. They would say, no, no, no. You'd get it to clean root canal systems, but you would also use it because it's a non-instrumental technology. We don't have to shape. So, Cliff, we're going to have stronger teeth post-endodontics. Okay, so everybody hold those ideas. What I got in the mail from tens and tens, if not a few hundred, gentle wave users is bleeding. There are commonly reported bleeding problems. I didn't say that. I have it from gentle wave users, okay? And if you're having a big bleeding problem every 2 or 3 cases, you don't, I don't. In fact, what most of them will say is I never really had but a few bleeding problems in a year, and now I'm getting it right along regularly. We had a female dentist weigh in all these portfolio of emails, and she says anesthesia is wearing off right in the middle of procedures. I've been practicing for 15 years, didn't notice this, but maybe all the agitation is pumping and opening up the physiology periradicularly. Yeah. Another thing you hear is post-op pain. My daughter almost went to the hospital, my daughter. So I was out of the country. The guy in town she always sees wasn't available. He was giving a lecture, and so she made a call and went to this guy. I won't mention his name. And he said, your dad's going to love it. I'm going to use his ProTaper files. I used to use his endo activator, but now I'm using gentle wave. We're going to do state-of-the-art. So she was pretty relieved and excited. And, well, anyway, she had horrible pain. And that's because it was probably, I don't know, either leaving tissue behind or pumping reagents inadvertently through the foramen. Now, what about the tissue? As the post-operative problems have been magnified through chat rooms, people have started instrumenting differently. And I call it shape shifting. So instead of having their normal protocol, Joe, your protocol, my protocol, whatever you do, you know, your terminal diameter, what you like for apical deep shape taper, they're now working 2, 3, 4 millimeters short. And they're saying the machine will clear the tissue from the apical terminal extent. But then when they show you the pack, there's no material in that. Your brain, my brain would say if it's devoid, you know, Newton's laws of physics, only one mass can occupy the same space at the same time. So if you really removed a plug of tissue, then hydraulically our filling material should have moved into vacated space. And I'm seeing a lot of cases filled short.
Yeah.
So then did it really clean out the plug? And comprehending or compounding this problem more, a lot of them have left more traditional cements to go to BC sealer. And there's a lot of problems with BC sealer, and the profession doesn't get it. It's a wonderful repair material. If you say like it's a calcium silicate material, it's like MTA, okay, so it's fabulous. But for a single cone, I did a show with one of the world's expert. Her name is Josette. You might want to interview her, Josette Camilleri. She's at Birmingham in the UK. She's a world authority on BC sealer. And she's a fireball lady. She's beautiful. She's fabulous mind. She's like really smart. And before I made the show for the Ruddle show, she sent me maybe 15 articles talking about how our final rinse solutions alter the chemistry of the sealer, how it resorbs, how it's carried away, how we lose the pH. If you have a high pH around a root periradicularly, you know, most lesions, as we know, are acidic. So everybody says, well, you know, if we could have a high pH, like calcium hydroxide is about 12. So if our silicates are really high pH, we're neutralizing the acidic, we should see faster healing. That's great, but how do you have a high pH? You have to be releasing material. It has to be breaking down. It has to be disassociating. And we're putting ions then into solution, and they're leaving the material, which begs the question, are we opening up the root canal system to secondary longitudinal leakage? So, you know, I could go on BC sealer, I won't, but I identified 5 major problems, but yet everybody is now doing single cone because their preps are so small, they can't get their armamentarium in to do some kind of a vertical, either single wave or classic shoulder, which is what I do with the new technology. So anyway, we're seeing people go from really well understood obturation methods over 50, 60 years, and now we're going to a single cone that has virtually little validation behind it, and the sealer is really suspect, and the sealer is immiscible. There is no chemical on planet Earth to dissolve in the retreatment situation, BC sealer. So if you have to retreat, they say, well, we have a cone. Good. We can get gutta percha out cliff. You just auger out your gutta percha. Now you got a pilot hole. Okay, so your instrument goes down the pilot hole. Now it starts to move out and cut north, south, east, west. But what about all the fins and eccentricities and loops and deltas off the body of the canal? You're never going to get that shit out. So I think we're setting up a future where we could see quite a few failures. And I think we need to go back and look at basics. And I think you might be old enough to remember Hydron from the 70s, came and went. You remember perfectly Resolon, came and went, class action lawsuit. And here we are, BC sealer. I predict it'll come and go. Again, great repair material in surgery and internal repairs for perfs, but I don't think it's a sealer, and we don't know what we don't know.
Yes, no, exactly. Yeah, no, I fell into the trap. I must admit with Resolon, I like the radiopacity of it. And can you speak a little bit, because it just got closed down, and I think a lot of people are as to why did Resolon just get pulled?
Well, I was asked to be on the Resolon team.
Yeah.
And I was invited by Martin Trope, who was the brains behind it. I wasn't even aware of it. Mm-hmm. So he flew out to the West Coast and gave John West and me a personal all day. I sat on his right, John sat on his left, he was in the middle, and we watched all his histology. When he was done, I said, wow, why am I using gutta percha?
Yeah.
Well, there's in life, Joel, you make a circle and you divide it into thirds. In life, there's the things you know. Well, I could do this. Maybe I should be really dramatic. I think Stuart likes it when we get dramatic. So we make a big circle. Oh, we won't do that. Well, yes, we'll do it because we promised we'd do it, Joel.
There we
Precious
go.
minutes. So in life, there's the things we know, there's the things we don't know, and there's the things we don't know we don't know.
Can you move it up just a tad for just a sec so we can see the whole circle? Perfect. Yep. Yep. Perfect. Yep. Yep.
So remember we always said I could be wrong on that. I don't know. We don't have to know everything.
Yeah.
Anyway, I think the main thing to say about that is we don't know what we don't know. So until we have more information, I think we should, Asian philosophy, before enlightenment, chop wood and carry water. After enlightenment, chop wood and carry water. So I don't think we have to just jump to something new because, you know, a lot of people did it today.
Yeah.
That's really crazy. I mean, Steve Buchanan said, I've been using curb pulp canal sealer for 40 years. I've never had a failure. I'm now using BC sealer. And you're going, who would give up 40 years of success unless you said it's taking him all day to mix it? Unless he says it's staining all the teeth he's treating? Unless he says he's having terrible, okay, easier, better, faster, do something different. But until something comes out that is better than what Joel's doing, hold the course.
Yeah. No, absolutely. Yeah. No, it's
Well, you know, the problem with back to Resilon, I don't ever teach anything I don't know quite a bit about. I'm not very smart in so many things, but the things I do try to be respected in, I need to know. So I had a school do some information for me on Resilon, and when we did a bioanalysis, we found out what the problem was. It has polycaprolactone. So polylactone, it is a resorbable material that's used in surgery in the body, and it was the main filler. So we say gutta percha is only about 18 to 22% gutta percha. And what's the rest? Fillers. So it's zinc oxide, you have an opacifier, Canadian balsam, you know. Okay, so Resilon. Well, it's about 18 to 22% Resilon. What's the filler? It's not zinc oxide, it's polycaprolactone. So that was what resorbed. That's why when you did surgery on your case or my case, 2-3 years later, it was still running. That's why cases never set up, the material inside the root. That's why so many washed out. I get calls from all over the country. People see one of their Resilon cases almost every day on their schedule, and they're doing retreatment. So I don't take lightly a new sealer, and just because it gets a lot of noise in the marketplace, we sometimes get fooled with the histology of a material that was validated. You know, it kind of reminds me a little bit of, what is it called? Hydroxychloroquine. You know, it was for malaria. It was for arthritic conditions, some kinds, other things. It was validated, but it was an off-label for COVID. Well, I would have to say bioceramic sealers are off-label for sealers, but they're fine for fillers.
Yes, yeah. And don't drink bleach.
So anyway, back to the I want to say one thing about GentleWave because I want to be really understood. You can really clean a root canal system.
Yeah.
But I told this guy, this group, that Ruddle has documented, John West has done this, hundreds of people have done this that have been working over the last 40 years. We can fill radiographic evidence. I didn't say it was clean or anything. We can fill about 2.8 to 2.9 portals of exit per every one shaped canal. So when I see GentleWave people just, they're thrilled. They're getting their first lateral canal. They discovered their first loop. Or maybe they're getting them more frequently because they saw it anecdotally. It was a sometimes event. So I'm happy for them, sincerely from my heart, but I'm wondering, well, where were you all those years I was teaching? You could have been treating anatomy, and it didn't have to take you a long time. You could have done it with an economy of time, and you could have shaped maybe a little better. And if you would have had some ideas like a $2 tip of an endo activator that's been out in the marketplace for 14 years, I guess I get cynical, the rush to buy something for $70,000 when Herb Schilder did it his whole life.
Yeah.
So I wonder, so to finish that part, you're really good clinicians because you know as endodontists, you've been around a lot of them and you teach them. We have endodontists with incredible skills, okay? We have the whole range of poorly trained, pretty much well-trained, and superbly trained. It's like a baseball team, a basketball team, you have every level on a professional team. Well, we have professional endodontists, we have the whole range because training varied so much between schools. There's differences in personalities, different parts of the country emphasize different things. So not everybody came out exactly trained the same. So a lot of people were 1 and 2 millimeters short, rarely saw the anatomy. So for Gentle Wave, it's really been a messiah. For people that already did it, they're going, what's the big deal? I've been doing it the last few years of my life for like less than $4 a patient. So I'm saying that in closing, but I will say with that good news, you will see more bleeding. You will see more post-operative pain. You'll break your seal, and sometimes you have to replace the seal. The biggest thing I see in webinars is people shape the whole canal nice. They they put the platform on. You know, that's 8 minutes, 6, 7, 8 minutes. The platform takes about 5 minutes to put the platform on. They'll say it takes less, but if you watch the people do it, it takes 5 to 10 minutes. So they have quite a bit of time sewed up in just putting the resin donut on the top of the tooth, then seeing the handpiece into it to get the seal. Then they got the 6 to 8 minutes of cycle time. Mm-hmm. Well, a lot of them are realizing you can't use it on wide open apices. You can't use it in some resorption cases. So all of a sudden, there's a lot of case selection. Your great dentists know that. Your great dentists have deep shape. They don't have all these problems. But a lot of the younger dentists that maybe didn't get trained to the same level, because a lot of the resins coming out now, they're so mechanical. They never learned the manual stuff. See, Joel, you learn the manual stuff. And then you applied the mechanical stuff to the manual stuff, and you just got better.
Yes.
But if you never really mastered how to negotiate an abrupt recurvature in the last 2 millimeters and hold your patency, maintain it, and get a great shape coronal to the terminus, then you're praying that your NiTi file will. You're hoping your reagent will get there. So good for them. It's great. It's going to be, I think, not a panacea at all. I don't see it as the future of dentistry. Nobody around the world can afford that unless you're talking about an elite group of, you know, maybe 1,000 people.
Yeah. No, it's interesting development, and it certainly has a lot of people looking at things. And one of the things I could never cognitively get around is that apical constriction. How could any device be able to gauge that through, the pressures and such things? But yes, it's been wonderful chatting with you, Cliff. We've covered a lot of great stuff. Hopefully neither of us are going to get sued.
Well, you know what I always like to say, the last time I lectured at the AAE, I usually lecture every year, every other year, and I've done it 35 times. I got banned from lecturing at the AAE after 2017 because I told the truth about something and I had evidence. And then a big company went in, paid $750 million to the board and said, get this guy off the stage. So I really don't worry about it anymore because to me, my job is to be what I've done the last 45 years of teaching, just tell the truth. I have all the evidence if anybody wants to see it. They're not from what you said. They're not what Ruddle said. They're from their users.
Yes. No, absolutely. On that note, I'm down to a minute. It's been wonderful. We got to do this again sometime.
Thanks, Joel. And I'm very proud to join you. And I like what you're doing.